In this video, I'll be showing you how to implement intermediate AI using Minimax. So what's an intermediate AI? It's one which wins where possible. It blocks your moves or just moves to an empty spot wherever possible in that priority. So I found a Tic-Tac-Toe game that kind of has the intermediate Minimax. So it blocks my move, and then if he has a chance, it just wins. Okay, but you could definitely win this. See, hopefully I go first. Okay, and there, and there. Okay, so you could definitely outplay it and win. So it's not a perfect Minimax algorithm, but it has a depth of just one. But that really works well. And that's what we're going to be implementing today. So Minimax uses what we call recursion, and recursion is just a method that calls itself over and over again. And as you know, that's a loop, and it's going to loop forever and eventually crash your project or whatever if you don't have a terminal spot in there. And terminal spots is a condition where the recursion actually comes to an end. You need that every time, else you'll have all this Stack Overflow exception in Unity and stuff like that. I had a whole lot of that while working with this, so try to avoid that. And a few references I used for this project. The one I used most, definitely this JavaScript implementation. I did have to change a lot for it to work, but it was a good layout for me to start with. Okay, it's right here. I'll post a link at the end of this video in the description. And there's this one here. Oh, this is a really good one if you just want to have more information and everything. It's right here. It's got game trees, tic-tac-toe board, talks about minimaxing, talks about depth, and that's it. And the last one would be it's just another website. No, not this one. It has still info on Minimax algorithms and tic-tac-toe. Okay. Recursion trees. Alright. So So Minimax algorithm here is just explained as a back and forth between two players, and the player with the current turn always has the desire to have its maximum score. So it's trying to maximize its score while trying to minimize the other player's score. So in our case here, we're trying to make the AI win, right? So let's see. This would be our sample game board. Draw straight lines. Alright, so this would be our sample game boards, and let's start with a game board with a terminal state. Okay, that's the game's almost coming to an end somewhere. So X and O's, let's say here. Okay. And maybe an X here. It's O's turn to play. So O is our AI player, and X is the human player, and it's O's turn to play. So how will we recursively evaluate this board to get a state? So I'm using different values here as a score. So if AI wins, it has a value of +10. If the AI loses, -10. If he doesn't win or lose, I'll just return a -50, -50, whatever that is. Okay, so this is how you recursively move around the board. So let's say I place an O here. we'll be switching the players. We'll place an O here. So we have a list or an array of scores. Okay, so if I place O here, what would be my score? Score is, there's no win here. So, but there's no win here for me. So I could just return a score of -50 since I don't win. Okay, so what if X was here? X doesn't win. So that's a score of -50, just adding it to my list. Okay, that's the first position. So we'll move on to the next one. That's across and down. And AI player here, he doesn't win, -50. And X place here doesn't win, -50. And here, if O player is here, he doesn't win, so that's -50. But what if the X player plays right here? Okay, he wins. Okay, so that would return a -10 for the AI player. Okay, next thing you'll do is sort through this list and find the maximum score, and that's your -10, and that returns this point, -10, and a score to your AI player. Say score of -10 with the point of 0, 1, 2, point of 8. Since it's a tic-tac-toe board, an array 0, 1, 2, 3, 4, 5, 6, 7, 8, representing the 9 points. Or if you're using a 2D array 0, 0, 0, 1 and stuff. Okay, but I kept my board simple, so it's just the car array called board, and it accepts all character values. So it accepts X and O's. Any character you put in would just mean an empty spot. So my empty spots are just represented with Z. And those are my actual characters. And I'm checking for, the way I'm checking the win is if every piece in a row like this, or diagonals are the same character, then that's a win. That's basically it. Okay. Okay, so that's an explanation for that. Let me pull up the pseudocode here. Okay, so I started off with a struct, AI move. Since I need to return two values, the score, I'm just using the score for the evaluation, and I'm actually returning a point to Unity. It depends on how your project's set up. Most people just return score, but I need a score and a point so I could have a reference to the scene. Okay, so this is a struct. You could use a class, and then this is a AI move. That's this type of AI move. It's basically just calls get best move, and get best move returns your best move. This is where everything is happening. Okay, so this is a recursion, and you need to establish your terminal spots here. Okay, and your terminal spot doesn't need to happen the first time, because if you call Minimax and your terminal spot just returns a value, it's gonna take that value and not even go through the rest of the board. Okay, so what I did was set a count, an integer type count, to 0, and in my terminal spot I have something like if count is greater than 1, and then it could start returning values, because I'll be calling it using the recursion. We'll see that better once we look at the actual code. So terminal spot checks for victory. If true, this is this right here. So it just passes the board and passes the player type. So it passes the board and a character. So let's say an O piece. This is a board. O, let's say X, X. Maybe this is the spot we wanted to play. So we put that simulation spot in here and we check if it returns a victory, true. We could say we need to return a score of +10 and that moves in here. Okay, so let's go down that list. It returns a score and a point. Okay, here I have a list of empty points. That's the point I've not used yet. And a player starts with O, puts O in that board space, and calls itself. That's the recursion. So once O is in that board space, it checks for the win and returns a score and stores that score in a list of AI moves. So it has a score and a point in there. And then I switch the player. So player is the AI, inverse would be the X, and do the same thing here again. So at X here, when I call this, X doesn't find the win, so it doesn't return +10 or -10. If it did find a win, it would return -10, but since it didn't find any, it would be -50, and we'll add that value to a list. Okay, and here we'll just compare those values. So my list has a +10 and a -50. It just chooses the maximum values, which is obviously +10, and returns it and say, hey, this is your best move. Your best move has +10, and it, obviously stores its point too. So it returns that best move. Okay. So let's actually look at the code. So this is how my scene's set up. In my manager here, I just have a board with character types. Just accept character values and stuff. Okay, so play. That C is not going to do anything since it's not an X or an O. So play. It blocks me off. If I let him play, he would win. Stuff like that. Okay. Let's look at the code. First, let's go to my umpire script. Let's see how the board's set up. So let's see, board. Board is just an array of characters with 9 spots, so 0 to 8. And I actually have win combos, so I don't use if and else statement every time to check the wins. So this is my win combos. It's a 2D array. So like about this spot, 6, 4, 2 would be 7, 0, 7, 1, 7, 2. So that's the diagonal 6, 4, 2. Just slant that way. So here, the columns are always constant, so I put 0, 1, 2, and let this iterate from 0 to 7. So at 7, 0, 7, 1, 7, 2, that would be our 6, 4, 2. And just check the win. Okay, I have a more truncated check victories simulation here. So that's basically what it is. It returns a Boolean type once you pass the board and play a piece. If anyone wins at any of those points, it returns true, else it returns false. And if it's false, our terminal state would give you a value of a score of -50 and still that point. Okay, so we have a struct up top. We don't really need this, and you don't really need a constructor for structs because it already comes with the default constructor. Okay. And win combos, that's just copying this that array of wins. AI move. This is the list we'll be storing all of moves in. I've not implemented the enums just yet. Umpire, that's a script. Empty points, that's getting it from my move tiles array. Just copying this empty points here. Test board, just for testing stuff. And this count was really important because once this run once, it returns a terminal state. And I don't want it to return terminal state, so I increased this count first pass, and we could let this return the terminal states to our recursive call right here. So it's calling itself again, and we'll be getting those terminal states and storing it in here. Okay. So if check victory board, player one piece, that's X, is true. If he wins, return score of -10. That's the index, that's point. Just print that and return that move. Else, if it's the O character in the board, return a +10. If it's a draw, just 0. Else, if no one wins or there's no draw, it returns a -50. So it's just an empty spot. Okay. And this is a recursive call with iteration. For the index of I is less than the empty spots on a board. Just iterate that. And then if players are AI piece, this is actually where it starts. If it's let's see. Okay, so if it's an O, we would just put O in the board. So set the player to O and then add it to a board. That's one empty spot. And we'll actually switch the player to player X so we don't forget. And the index just stores the point. That's empty point here. I stored my game objects as in actual numbers. So I'm just using a system that convert to int to get the name as an integer type. Okay. And this var here is just an AI move. It's pretty much the same thing. And we're getting the best move, getting a return type. So we're getting a value and storing a move.score. That's this move here. .score is equal to this result score and this results point. And we'll add that spot to a list. We'll do the same thing. Since we switched players to X, we just check our terminal states again and add it. And that's gonna happen for all the empty points, just like I showed you. Happen for all the empty points here and just add them to the list once it's done. And you wanna actually empty out that board piece. So I'm just setting it to Z. So it's neither X nor O. So it's empty. Okay. And that's just debugging stuff. And here you actually, this is all you need pretty much. So this is just sorting your list. So first of all, we set the best score to some like -infinity, but -10,000 is probably what you go with. Even -100 would work. So if this score is greater than best score, it just sets it to makes our best move I. Okay. And our best score is AI moves.score. And that's all you need. Okay. So this plays really well, but just like the website I showed you, you can easily beat this. So it doesn't play really smart, but it's gonna block you at every point it gets. It's gonna block me right here, but it's still gonna. Oh, actually won that game. Let's see. Play better. Hopefully get this win. Alright. So doesn't really play smart, but it's gonna block you. It's gonna win when it has the chance. So how can we improve on that? And that would be adding what we call depth. I haven't actually had a chance to really look at this, but let's see. So it'd be something like this. Trying to implement depth to this. That's what I'm going to be looking at next, so I don't really know much about that. But this game tree was really confusing because, let's see, move this out. Okay. Right, so what this game tree says is that when I tried implementing this, I failed horribly because it just wasn't working out for me. So what this looks like to me is that the AI player will play first in all the empty spots, and let's see, and gets a minimum value from these two spots. Okay, and the AI would play only after his opponent has played, and gets the maximum score from two minimum scores. That didn't really seem right. What that would look like would be, since I'm using +10, -10, and -50. What if the AI played two spots and had maybe a chance to win, -10, and an empty spot? Okay, minimum of these two values would actually be -50. And if the AI is depending on the opponent's score to play, it would actually lose the game since the AI wins at some point here. So I didn't really understand how to implement this. Maybe it's when I get into depth, I'll understand that better. Okay, but this is how my game tree looks like. So let's say 0. And so this is the human player. Maybe it has a -10 here, -50. The human's trying to maximize his score, so maximum -10. And we have our AI player playing the same spots too. Let's say he loses here, and he loses -50. The max is just going to be -50, and we're returning our maximum value. And that's -10. This would actually let my AI block the human player. Okay, if we had a case where this was actually 10, that means I win at some point. AI's maximum, so 10, and we're returning a maximum of these two values. That means I would actually go for a win of 10 instead of actually blocking the human. So that's how my game tree works, and I think I've pretty much covered a whole lot. And I don't know if you've noticed this, but I think my AI character just starts at 0 every single time, and you could prevent that from happening by doing a list shuffle. I think I've used that somewhere before. An extension method that just lets you shuffle the list, and you would actually use it like this, something like this, and it would shuffle it. Maybe it starts off with a different point. That's a good point, instead of starting up with the first in the array every time. Okay, so this was really difficult trying to implement the algorithm because I kept failing over and over. I tried Minimax. It's a variation of Minimax. I tried a whole lot of stuff. C++, C#. and JavaScript. I just watched different videos and finally was able to implement mine. So yours may be different because of how you set up your board, but just don't follow everything in verbatim. Try to make it work for you. That's it for this video. Thanks for watching. Bye.